Hello, and welcome to the 2022 Design Expo presentation for the Michigan Tech Aerospace Enterprise. Today, we will be telling you a little bit about the enterprise, going over what projects we have been working on, and what our plans are moving forward. Let us begin. The Aerospace Enterprise is a collection of undergraduate students that are collaboratively exploring the aerospace industry through various hands-on projects. The program is composed of majors from all corners of campus, working together to design, build, and test multiple small satellite platforms. The enterprise has two primary objectives. The first objective aims to educate the future leaders of the aerospace industry by providing undergraduate students with hands-on space system engineering experience. The second objective aims to advance U.S. space technology by solving real-world problems. Not only are these problems challenging, but they are also directly relevant to current U.S. military and NASA needs. Students get to learn about satellite systems while also completing work suitable for the aerospace industry. The program was founded by our academic advisor, Dr. Brad King, back in 2001. Since then, it has helped over 400 students obtain their undergraduate degrees from Michigan Tech. As of now, we are currently home to 78 active members from over 13 disciplines across campus. We have two on-campus facilities that we operate out of, those being the clean room and the aero lab. We are also actively funded by two well-known satellite companies, which allowed us to successfully design and launch one satellite into space, not to mention that there are two more on the way. Now let's talk about one of the most recent problems in the space industry that our group has been working on. Over the past few decades, space technology has advanced such that satellites can now take up less space than a loaf of bread. The decrease in mass and volume allows for cheaper rides to space, meaning that the space environment is now more accessible than ever before. This increased accessibility has led to thousands of new active spacecraft in orbit, creating significantly more traffic in space. As you may know, with automobile traffic, having more cars around you on the road increases the risk of accidents occurring. This is also true for satellites, especially when it's difficult to be aware of other satellite activity. This increased traffic in space has created new risks for interference and has necessitated new methods of persistently monitoring the space environment. The Aerospace Enterprise's response to this issue is the Auris mission. Auris is a pathfinder mission whose goal is to demonstrate a low-cost platform capable of exploring the interference potential of geosatellites. This mission will feature a small satellite that's comparable in size to a shoebox that measures the antenna beams of communication satellites to further characterize their activity in space. Modern communication satellites can potentially create both electrical interference through interfering signals, or create physical interference by colliding with other satellites. The Auris mission will allow us to explore both of these types of interference in an attempt to further the understanding of space domain awareness. Let's go ahead and talk about how we actually plan to do this. There are two main objectives of the Auris mission, the first being called beam mapping. The Auris spacecraft will be flying through the antenna beams of the target satellite. As it does so, it's going to use its own onboard antenna to measure the power of signals being emitted by the target satellite. After passing through the beam of that satellite multiple times, we'll be able to stitch together these power measurements and create the contour plots that you see in the lower left-hand corner of the screen. The other mission objective is called multilateration. As Auris measures the strength of the target satellite signal, it's also going to take a timestamp of when it receives said signal. Meanwhile, 3 additional ground antennas will receive the exact same signal, but at 3 completely different times and locations. Knowing the location of the 4 receivers, as well as the time in which they measure the signal, will allow an operator to backtrack the signal to the target satellite and approximate the coordinates of the satellite in space. Having both location knowledge of a target satellite and a map of its outgoing signal will allow an operator to better understand the characteristics of a specific satellite just by listening to its signals. So that was a little bit about the mission, but how does an undergraduate student team actually design and build a satellite capable of doing all of this? The secret to designing the satellite is following the path of what we call space systems engineering, which is the concept of taking a project from its conception all the way until its final stages. First, you determine the mission, or what you plan to do when you're in space. Then, you define a list of requirements for the mission, which then guide the subsequent design phase of the spacecraft. After the design is complete, then you move on to actually procuring and testing the hardware to specifications given by your list of requirements. Once testing is complete, the spacecraft can finally be launched into space and begin its mission. So where is Auris on this timeline? Auris is currently in integration and design phase. After spending 3 years in the design phase, these plans are now being put into action by ordering all the design hardware, connecting them together, and testing their functionality on the ground. And that is what the next 1 to 2 years will look like for Auris. After that, the spacecraft can launch and begin its mission in space. This is the roadmap the Aerospace enterprise uses for all of its satellite projects, and will continue to use this roadmap for all future projects. So we've talked a little bit about how Auris is exiting the design phase, so what has happened in the past year or so? The biggest milestone to date for Auris was winning the Flight Selection Review in August of 2021. A small group from the Aerospace enterprise traveled down to New Mexico to present the Auris mission to a panel of judges and aerospace professionals. It was here that Michigan Tech and the Auris mission were pitted against 9 other universities competing for additional funding and an opportunity to launch. Lo and behold, Auris was selected as one of 3 missions to receive funding and a guaranteed ride to space. And of course, this opportunity could not have been made possible without our diligent enterprise members and our supporting Michigan Tech community. After winning the Flight Selection Review, the Aerospace enterprise took off with testing at the beginning of the following semester. Rather than designing the satellite, the team shifted their focus to creating and running their own hardware tests. Here are some examples of tests performed throughout this semester. The image on the left showcases our communications team testing their radio component, which will communicate information to and from the satellite when it's in space. The image on the right shows the testing of the power conditioning unit, which converts energy generated by our solar panels to safe, usable energy that can be stored on an onboard battery. As you can see, our team has been hard at work conducting their tests and getting hands-on experience with testing real satellite hardware. To help with all of that testing, the company supporting the Auris mission taught an on-campus course called SatFab. This 2-day course taught members of the Aerospace enterprise skills that will be required for assembling the spacecraft and its many components. They learned techniques such as soldering circuit boards, properly torquing bolts, and creating wire harnesses. This was a wonderful experience for our members that taught them skills to be used not only for the enterprise, but also for their careers once they graduate. In conclusion, the Aerospace enterprise is a collection of undergraduate students that have been working hard to design and build a satellite, which of course is not an easy task. However, the generosity of the Michigan Tech community, alumni network, and dedicated student body have allowed the program to be where it is today. Thank you all for your continuous support. If you'd like to receive regular updates about the Aerospace enterprise or the Auris mission, please follow our various social media pages listed on screen. Thank you for your time, and we hope that you enjoyed.